Linguistics to Demystify Financial Text. I did this under the supervision of Dr. Sohom Ghosh. So, firstly, I would like to pay tribute to Pushpok sir. He is the godfather of NLP, and I am fortunate that I could meet him during a course conference, and I got the honorable mention for the YRS track for presenting my part of my PhD thesis in the conference. So just a little disclaimer before I formally begin. The work is a result of my PhD research done here, and it solely represents my own views. It doesn't have anything to relate with the academic institutions or any of my past employers or present employers' opinion. Okay. So I will start with a story, and this story you can relate to it from three different kinds of people in India. I mean, I am focusing on India, but it's replicable for the world as well. So you see three persons over here. Now they represent one strata of India. So first I would like to introduce Shankar, who is from India 1. India 1 means he earns extremely good. He lives in Mumbai. He invests in stock markets, mutual funds, and so on. Now with the markets troubling and with the markets changing, the rapid dynamics of the market, he is a bit worried. He is not sure that whether the amount he is investing, whether he will get proper returns or not. Next, I will move on to Indira, who comes from India 2, the second strata of the society, who is a government school teacher. Now, she is a strong believer of investing in assets like fixed deposits, gold, mutual funds, and so on. She doesn't invest in stock market. Now, with her, the problem she is facing is the amount of returns she is getting from the fixed deposits is not up to the mark. It's not able to beat the segmental inflation. So that's a cause of worry for her. Third, I would like to introduce someone from India 3, whom I would like to refer as Kanai. He is a daily wage worker. Now, with him, the problem is he has a son named Hari, who is around 21 years of old. Being influenced by influencers, he is now investing in cheat funds so that he is able to buy a lavish phone. Now you see, people are from the different strata of the society, but all are financially worried due to some reason or the other. And next, I would also like to highlight about the government of India. Now, government of India has made a mandate by 2070, it will be completely carbon zero. It will be carbon neutral. So since it will be, it has pledged to be carbon neutral, the investments it is making, the kind of policies it is they are defining, that has to be with this mandate. So there has to be this green component where there has to reduce. The people and the citizens as well as the industries has to reduce emissions. Otherwise, the EU and other nations will impose carbon trade. So even the government is worried. How can they implement all these things? So not only the citizens but also the government is worried when it comes to managing money. And this is not just in India. I portrayed the picture of India, but this is replicable worldwide. So I would like to ask you a basic question before I formally begin. Are you financially literate? Now in India, the concept of dealing with finance, it has been time immemorial. People have been worshipping Lord Lakshmi, Lord Kubera for wealth. But when it comes to managing our own money, we resort to something like taka mati mati taka, something like that, where we don't focus specifically on our own wealth, but God helps them who helps themselves. So how can we inculcate the thing which is already in our nation, already within us, and become financially literate? So I will first like to define what is financial literacy. So financial literacy means the art of managing money. Now I would like to present some statistics before I formally begin. So till now I have been telling these stories from different parts of the world and India. Now here I would like to concretize and put some number to these stories. First number is 1 out of 3 adults worldwide, they are financially literate. So the financial literacy rate is just around 33%. Okay. In India, it's only 27%. Now people all over the world, they are unable to manage their money in an efficient way. Now let me just portray the picture of India in a little bit more details. I was talking of Indira. who was a traditional investor. Now people who have been investing traditionally, for them the amount of the return on investment has been decreasing. People who have been investing in stock market, it's not that they are earning huge amount of money. Less than 1% of the active traders, they earn more than fixed deposit rates. So there are also that difference in financial knowledge and the application of financial knowledge that exists. Now India has a mandate to become a developed nation by 2047. So for that, the per capita income needs to increase from $2,000 to $13,000. How is this possible? India has grown over the years. The Sensex, it was around 800 in 1990. It has moved from 800 to 50,000 during 2022. So India is moving, India is progressing. But if you pick up the segments within India, they are not able to manage their money better. And this story is not just India. Here I have the world map. You see most of the developed nations, they have the financial literacy rate more than 65%. But India is drastically low. It's just 27%. And the same story repeats for other nations like India who are in the developing stage. So these are some of the facts which I presented. Now the other fact is, the richest 1% of the India, it owns 40% of the country's wealth. So there's a huge wealth disparity which exists in India. And India, it has a population of around 125 crore. It might be a little bit more, 130 crore or something. But there are only 950 registered investment advisors. So we don't have so many investment advisors to guide us. Finally, I would also like to bring in one more news article that increasing financial literacy during the pandemic, it's essential for India's recovery. So,
how long?
Total around 30 to 45 minutes discussions. Now, I introduced you to all the stories. The facts which I was presenting about the government of India being worried. You can see that in budget 2023, there has been analysis of green finance and roadmap where the government is making policies so that whatever thing is coming into the picture, I mean whatever policies are being made, those policies are in line with the green investment theme. They are not against our environment. Similarly, for NSE, it has also set up a social sector exchange, and about Hari, who I was mentioning, who is getting influenced by influencers, is investing in cheat funds. For him, this news article that influencers are using fake screenshots to run scams, and they are scamming the people. So these problems are evident, they exist in our society. We need to deal with them. So for that, I would like to distill whatever I presented into certain themes. These themes are inclusive investing, improved investing, impact investing, informed investing, and index investing. I will discuss each and every, so each one of those consists of one chapter of my thesis. I will discuss each and every one, or each and every themes specifically. So the outcome which we are focusing on are increasing financial literacy, reduction in wealth disparity, economic prosperity of the nation, which would finally lead to a sustainable future. So this is the structure of my thesis. I have started with the overview. This got published in Codes Command, CIKM and other places. Then followed by inclusive investing. By inclusive investing, it means that how can we make the process of investing more inclusive so that more number of people are able to invest. Improved investing is improving the overall process of investing so that people are able to make investment and the process is hassle-free. Impactful investing, it relates to the green investing, where we will be targeting on focusing on factors which relates to sustainability and ESG. Informed investing, this is something which I was just discussing before, that being influenced by influencers. So how can people make rational judgments and informed judgments and not get allured by whatever is present in social media. Finally, index investing, this is something which I have done specifically for India. What are the things which we can do in India? And this also got published in Elliott Calling and other places. And combining all of these, whatever I have done, to make my research reproducible, and so that people who take up this kind of research in the future, to enable them to do better research, I have also created several tools which which researchers in future will be able to readily use and progress. Okay, so this is an overview of the papers and the various venues where I have presented my research paper. It contains almost 4 out of all the continents. Okay. So before I formally start each and every chapter, just an overview of the contributions which have been made, which I have made. So there have been 16 tasks which I worked on, 8 languages which include 3 Indian languages as well, Hindi, Telugu and Bengali. 8 datasets, 8 new datasets which I have created along with using other people's datasets. I have contributed to 8 datasets, 6 tools and which resulted in 24 research papers. So publication venues include key venues like the web conference, Elred, CIKM and so on. And yeah, I have received some travel grants as well, and in most of the shared tasks in which I collaborated with others to participate, we have gained top ranks like first rank, third rank, second rank, and most of the top ranks we have achieved there. So this is the overview of my contributions. Now contribution doesn't come alone. There are several rejections. So I mean we tried to get paper published in various top tier conferences. So there have been certain rejections as well. So yeah. So first chapter is inclusive investing. In inclusive investing, there I have specifically worked on readability and reachability of financial text. So this I presented before. Now what do I mean by readability? Now readability means how can we quantify how much readable a financial text is, and reachability means how can we ensure that what are the content which is being created, to how many people is it reaching? Can we ensure that whatever content we are creating is getting read by more number of people? How can we ensure that?
The context is dependent.
Yeah, so given a text, suppose there is a specific sentence, how can we transform the sentence keeping the context same so that it reaches more number of people? So,
And also improving readability?
These are 2 separate tasks.
Separate?
Yeah, we didn't.
Exclusive?
Yeah, we didn't combine them. Yeah, it would be a better thing to combine them. But we came up with the readability first, then we came up with reachability. So for readability, what we did is, so I got inspired by a paper from AAAI which dealt with readability of Bengali sentences. They took papers, they took the text content from textbooks, Bengali textbooks. So whichever textbooks contain the contents were from class 5 or lesser, they have classified it as easy and the rest as difficult. Along with what we have done is generic sources like Investopedia, Economic Times, then The Economist, NCERT, whichever is available for the public to read in general, those we have considered as simple text, and whatever present in financial textbooks, the definitions, terms and the definitions which are present in financial textbooks, for which the amount of knowledge you need is graduate level or up, that we have kept separate. And that we have classified that those are difficult and these are easy to read. So we have both kind of texts. What we have done first is we benchmark. We use the standard readability scores. We try to get an understanding that what are the standard readability scores like FLES score, SMOC score and all doing. We found that
it's created by you.
Yeah. So this is yes.
There is a question that the presentation.
So these terms and the definitions, they are present readily. We have just manually verified and created this data set, labeled data set. Now our first contribution is creating of the labeled data set. We have this, we benchmarked it with the standard readability scores. What we found is they are doing okay job but not a great job. So we trained at Finward based model.
How many annotators are there? You know?
So there were 2 of us. So what we did is the data was already annotated. We already knew the labels because the text which we are getting from graduate and above levels, the terms and the definitions which we got from the books, specifically for students who are graduate and above. For them, we have said that they are difficult. We will say those are zeros, and the ones which are simple, we will say those are 1. So it was already annotated. It was already labeled in that way. Then we went through the. I mean, just for including human in the loop, we went through the entire corpus to ensure that everything is fine. So we trained a Finbert-based model, fine-tuned the Finbert-based model for classification, which the amount of accuracy which we got is better than any of the classical models. And we also created a tool called FinRead. Finally, we come up with this FinLancer thing, which we call as Financial Language Simplifier. What it does is, you give it a sentence as input, it will use a paraphraser, T5-based paraphraser, come up with multiple paraphrases. Among these paraphrases, which one has which one is most readable, which one has the most readability, will be displayed as output. So our contributions is the FinRead dataset, which has around 13,000 financial terms and definitions, a FinRead tool, and a FinLancer tool to simplify financial text. Next is something which I would like to discuss. This was published in the Jadavpur conference last year.
Just a minute, go ahead, Ms. White.
Yes, ma'am.
What do you mean by simplification?
So simplification is making it more readable, enhancing the readability. Yeah.
There is some index that readability is good or poor, like that.
Yeah. So the data set which we created, we had kept a holdout set. So within the holdout set, we are saying that how good our model is able to classify. And here the thing is, yeah. So next is this reachability. So reachability is, you see, there are two tweets from White House. This is this tweet and this tweet. The content of the tweets are same, but one has received, you see, 328 retweets. Another has received 2081 retweets. Now, why are they different? This is just because of the content. Because the whatever is being discussed, that is the same. The way it is being written is different. That's why it is. That might be the probable reason for which one is more reachable than the other. So we developed a framework to estimate this. First, I would like to walk you through the architecture. So, in this architecture, what we do is, usually in the transformer network, there is an encoder network followed by the decoder network. We thought that let's tweak it. We'll use the decoder first and then the encoder and see if it is beating the transformer architecture in general. So what we have done is, we take this input text T1 and T2. These are two input text. Now our target is, given two input text, how can we determine which will reach more number of people? So what we do is, the final architecture which we came up with, we'll first prompt and large language model. We tried with ChatGPT, we tried with several other things. This was way back in 2023, initial versions were coming up. Claude gave us the best results. So we prompted Claude, we got the response. This, we added it to the, we just appended it to the original input text. Same we did for text 2, and then we use a flying robot model for classification. The architecture which we proposed was performing better than Claude separately, ChatGPT separately, and Flying T5 separately.
Claude is kind of prompt engineering tool.
So Claude is just like ChatGPT.
It's made of Google.
No, Claude Anthropic is another company like OpenAI who has created this model. So we tried with several things. This one performed best for us. Now, so what here what we have to give input is two text, and it will tell us which of the text will receive more number of retweets. Now, for a content writer, that is not usable, because a content writer, we can't expect a content writer to write the same thing 5, 4, 10 or 12 times. What we have done is, we have also incorporated a paraphraser. So a content writer will write one text, it will get paraphrased, and automatically our model will give that version of the text which will reach more number of people. So for this, the data set we created is, we collected tweets. So back then, Twitter data was available for academic users for free. So we collected the tweets. We then grouped those tweets which is similar, but there's a difference in the number of retweet counts. Accordingly, we created the final data set.
Your tweets are related to financial.
Yes, right. Yeah, so we looked at the content of the tweet. Those tweets are related to the financial domain. But this is again extendable to other domains as well, this approach. So yes, here our contributions are, firstly we present a crowd reaction assessment data set. Crowd reaction estimation data set. we proposed a new task called the crowd reaction assessment, and then we also proposed a new architecture which we refer to as generator guided estimation approach, GGEA. Now I'll be moving on to the next chapter, which is improved investing. By improved investing in, suppose anyone who is not literate, if he or she wants to make investments, there's a hassle, there's a certain process he or she has to go through. How can we simplify that process so that it becomes easy? So these are some of the news articles which I presented. Yeah. So improved investing. Here I would like to discuss two things. Firstly, detecting hypernyms of financial terms. By hypernym, it means the generic form. Suppose I don't know what NPS, PPF or PF is, but if I know what Provident Fund is, and if I say someone that you don't know NPS or PPF, don't worry, it's a kind of Provident Fund. So Provident Fund is a generic form of the specialized funds. So how can we detect hypernyms from financial terms? The other thing is extracting relationship between two financial entities. This I will discuss as I move on with the presentation. So here is the example which I gave for PPF NPS. The same example, this is for the US context. We had the data for the US context, and there was a hierarchy which was available for these terms. So like within debt temporal, there is CIP and debt pricing. Within this, we have this. So you can call it a kind of ontology or knowledge graph where we have various financial concepts and they are arranged in hierarchy. So for this, we came up with not just an architecture. The architecture here is pretty common, but what we came up with a sampling strategy, which helped us in improving the performance of our model and beat whatever was existing. The sampling strategy we incorporated here is, suppose we had limited number of training sets. Firstly, so the training set comprised of a specific financial term and what is the given hypernym. Okay, so a financial term can be NPS, hypernym can be retirement fund. Firstly, what we did is expand this retirement fund. We got the definitions of the retirement fund in place, and then we created negative samples. So for the dataset which we had in place, there are only positive samples. We have one term and we have the hypernyms. Now, when we are training a model for classification or some kind of model, if we can also have this negative samples, that this is the term and this is not the hypernym, the model will learn to distinguish better. So we thought that how can we incorporate that within the dataset which we have? So the way we did is, suppose I take this regulatory agencies. For this, if I am taking something which is not in its parent, which is from some other parent, like equities, I will say I am taking suppose share and here basket. They are not related to each other. So I will say that for them we will have the similarity as 0. And for the ones which are within the basket, we will say the similarity as 1.
In feature means you are saying the decision and
yeah. So I am training a model. For training the model,
supervised?
yeah, it's a supervised model. So for supervised model, the dataset which we had has only the positive samples. This is the term and this is the hypernyms.
Positive sample is treated as the class level.
Yes, all the class levels.
Include negative also.
Yeah, so all the class levels are positive. We don't have any negative samples.
So it's a single class problem, right?
Yeah, so but in order to make the classifier learn better, we also need to show that what are the chances in which it may do a mistake. So we also need to incorporate some of the negative samples so that the classifier is able to distinguish. So we had only the terms and the hypernyms.
Negative samples are not available.
We had to create it. It was not there in the
It's
dataset.
not available in the
It was not available in the dataset. So what we did is we thought that let's do it this way. We'll for this given term, we'll look for other parents. And suppose I'm using corporate bodies, I will use debt and I will say that for the.
You can classify also the positive samples. Means some more positive, less poorly positive.
Yeah, eventually we brought in that flavor as well because we used the similarity. So instead of treating it as a sentence classification problem, because suppose I treat it as a sentence classification problem.
Based on the similarity score, ultimately.
Exactly. The problem with classification is if the number of classes are limited. If there are
अभी डेट क्या देखছি
আর ম্যাডাম বেশি নেই, তাও তুমি শুনতে পাচ্ছ না, বসো। ও রামচন্দ্র সেই মাস্টার মশাই ছিলেন, এগুলো আড়াল করছে।
So the problem with classification is, suppose there are 5 classes. Now a new class comes up. We won't be able to add this to the list of to this classification model. We need something separate for that. So we thought that let's try to deal with that problem as well. Even if new classes start coming up, we should be able to deal with it effectively. So we took these terms, instead of looking at their parent, we went to other classes, I mean other parents, and from there we took their terms and said that for them the class is 0. And if someone has the same parent, we'll say the similarity is not 0, not 1, but somewhere in between 0.5, 0.4, 0.8. Accordingly, we came up with this negative sampling logic. And then we used a standard sentence word architecture. So this is pretty much a standard. The only other thing which we got, which we did to get more, get better results is we had all these things in place. Then we also had, we first used the sentence word architecture, which was taking the term and the label as input, and when they are similar, they are bringing them closer in the embedding space. And when they are farther, the embedding was getting refined so that they are pushed apart. So we created 2 such models, one with FinBut, another with FinISH, and then whatever output we got, we ensembled them, we mixed the outputs.
Pooling is for dimensionality reduction.
This pooling is, we have this embedding. Now from this embedding, yeah, so for embedding we need to,
embedding vector goes to pooling.
yeah.
For what purpose?
So there are the number of terms were not constant. So in some cases there were suppose 3 terms, there are 4 terms, in some cases there are 1 term, to bring all them together into a specific number of dimensions. So it's a kind of dimensionality reduction. Suppose there are 5 terms, but I have a specific dimensional vector. I want to take do mean pooling so that everything comes into one specific dimension. Yeah. So our contributions here is firstly the negative sampling, and secondly the system state-of-the-art system capable of ranking hypernyms for a given financial term. Next, I would like to present relation extraction. So what do I mean by relation extraction? Here I would like to present a sentence first. Elon Musk is the CEO of Tesla. Elon Musk is the person, Tesla is the company. What is the relationship between them? Can we understand it somehow? So here the dataset which we had is, the dataset already had the relationship, already had the entities. We needed to find what is the relationship between them. So we tried with several architectures. In fact, back then Llama 2 was very popular. It has recently come up. We had also benchmarked with Llama 2 under 0-shot settings. What we found is, the final architecture which gave better performance than all other is this one. Here what we use is, we firstly mask one of the entity and get its embedding using BERT ACC. So the BERT ACC is a specialized version of BERT which has been fine-tuned on ACC documents. So like in India we have SEBI, in US there's ACC, and the companies need to file their quarterly earnings there. So BERT ACC is a standard model which is fine-tuned version of BERT on the ACC documents. So we took that and we got the contextual embedding of the mask token. Here also for entity 2 we masked it and we got the contextual embedding. Now we had 2 contextual embedding in place. We also added some other features. Like what is the type of entity 1? Like entity 1 the type is person, entity 2 the type is company. Then which relationship group do they belong to? And all this we have trained a neural network based classifier which is taking this contextual embedding into place in addition to the engineered features to do the classification. And this framework performs better than all others. So here we present a framework, we name it as MOAT, mask one at a time. And we also benchmarked it with some of the open source large language models which are available. So I would like to move on to the next chapter, which is impactful investing. Now, previously, people used to focus on risk and return, that I am investing so much money, how much return can I get? But there was no concern about the environment. This is gradually evolving. In addition to risk and return, people are also concerned about environment. That the investments which I am making whether it would lead to global warming, whether it would lead to more carbon emissions. People are now being concerned about that. And there's a mandate from the government as well, as India has its clean goals. India has the goal of being carbon neutral by 2070. So how can we make the investment process greener? These are some of the snippets which show that this is how real it is, how kind of what kind of problem. I mean, this is the news articles are also highlighting this. You can get an essence of how important are they in today's world. So here, the contributions which we made is how to, firstly the problem statement, how to ensure that the investments are towards the betterment of the earth and have a positive effect towards the environment. First task which we dealt with is detecting ESG and sustainability related issues and impact, assessing ESG impact type and assessing ESG impact duration. Most of them are classification tasks. And first task is ranking environmental, social and government related concepts and assessing sustainability aspects of financial text, detecting issues related to environment, social and governance, a low resource framework for multilingual, ESG impact type, and then finally we also I would like to also present fine-tuning language models for predicting impact associated to financial news articles. Now here I would just like to give a disclaimer before moving on. The tasks are not, these are mainly the shared tasks, and our contribution, for most of them the standard architecture worked well. So here our major contribution is not the dataset, not the architecture, but some kind of learning which we have, which helped in developing this kind of datasets for the Indic NLP chapter, which I will be discussing later. So since here the contributions are not that huge, I will just briefly describe them for the sake of completeness. So first task was given a term. We need to find what is the concept, which ESG concept it is related to. And then there is a second task where we have an text and we have to classify it as sustainable or unsustainable. So these are pretty simple tasks, the same architecture we used. We got results here as well. This architecture I had already discussed, so I am not going deep into it. For subtask 2, it was again a simple robota model which gave us the output. We didn't have to do anything else, but this gave us good results. And for the ESG issue type detection, it is also a ACC based model, ACC word based model. Fine-tuning it gave us decent results, and we came up with a tool as well. So till now, whatever we have done, it was just a simple shared task we are participating in. Now, the scope increased. In addition to English, we also have Chinese, French, Japanese, and our target was for this shared task that can we come up with a unified framework which will deal with all of them. Because these are also some kind of low resource. Chinese is not a low resource, but Korean, French, these are low resource languages as well. If we are able to crack this for these foreign languages, the same thing we can incorporate in India as well. So let's give it a shot. The final architecture which we came up with is, we have these original datasets in different languages. We tried training, fine-tuning multilingual but for them, for classification. That didn't do well. What we did instead is, because all the multilingual models, they are not finance domain specific. But for English, we have this finance domain specific Finbert and other models. What we did is, take the datasets from other languages, translate them into English. For English, we have a good paraphraser. So we can increase, by paraphrasing, we can increase the presence of the minority classes. And after that, we trained the classification model. This performed way better than all the other approaches which we have been trying. So for low resource languages, this was our go-to approach. That if it is not a high resource language, first translate them into English, create more samples using paraphrasing for the minority class, and then train some of the finance domain specific models like Finbert, Tone and others. They are giving much better results. Now, this task, it is also similar to what I have just presented. The same framework which we did for this previous task worked well here as well. So we have these news articles which we needed to classify. So we use Finbert, Robota and BERT, and the same kind of paraphrasing and translation worked, this same architecture performed better as well. So here our contributions are trained sentence transformer model, created an ESG related tool, a low resource framework, and also we fine-tuned Robota model for classification. So how are the learnings from this chapter translate that for the Indic domain that I will be discussing in the last chapter. But before I go there, I will just briefly touch upon informed investing. Now, in informed investing, there are manipulations which are being done by influencers. Then there are some celebrities who are posting certain screenshots based on which people get allured and make wrong investment decisions. How can we make this process better? How can we ensure that people don't get allured and all things are okay in place? So, informed investing, here the main motto is how to safeguard investors from misinformation. Detecting in-claim numerals, that is the first task. Second is detecting exaggerated numerals in financial text, estimating profitability and loss from financial social media, deciding trustworthiness of social media posts by executive and financial argument analysis. So first is for the first one, we already had this data set where each of the social media posts, they were marked with a profitability or a loss statement. The first task was given to social media posts which will have more profitability. Which of the social media posts will result in more profitability. That annotated data set was also there, already there. We trained models to automate this process. Now the model which performed this is for the Chinese. The entire data was in Chinese. We didn't go for a translation because Chinese is already a high resource language. We had financial models which were specifically trained for the Chinese domain. So for this, what we did is we had to do a group by pair-based classification. We had two texts and we have to come up with a label. And also the individual profitability and loss were marked for each of the texts. So we trained a kind of a regression model which will be able to figure this out, that given this text what will be the profitability. We did this for both the texts present in a pair, and accordingly we did the classification. The second task was, given a set of financial text in Chinese, how can we rank order them in terms of profitability? So the model which we trained for the first task, that we used for a given financial text, we got the output, we got the profitability. Accordingly we ranked and got this output, and we presented this at a shared task organized by FinNLP at EMNLP 2022. Now I would like to present claim detection. So what does this claim detection means? Let me just walk you through it. This is the sentence. Last year our profit was $2.2 million. Now this year it will increase to $3 million. We had this annotated data set. Here this is something which has already happened. Okay. So for this, the data set which we had received, it was marked as out of claim. Whereas this $3 million, it was marked as in claim. Now can we come up with a model which will be able to classify this kind of numerals present in the financial context into in claim or out of claim? Generally what happens is, whenever someone is reading any news articles or consuming anything from the social media, if he or she comes up with these numbers, that might confuse them. And we were doing this task in somewhere around 2022. Back then the language models, large language models, whatever were existing, they were not capable of dealing with numbers better. So this was a challenging task, and we thought that how can we do a better job in this? Although it's a simple classification task, but since language models were not able to comprehend numbers better, it was a bit difficult. So the architecture we came up with is a kind of ensemble architecture for which we had two different Finberts trained for different context sizes. By context size I mean the number of words I am taking before and after a given token. So we trained a Finbert classifier for context size of 8. We also trained a Finbert classifier for a context size of 6. And then we used the BERT embedding of the target numeral along with some engineered features, followed by a logistic regression model. All this we ensembled, and we took the majority voting from them to finally come up with the resultant classification score, which performed way better than other architectures we have been trying. So here our contributions are firstly to create a system, the architecture which I showed right now. Along with that, we came up with two tools which we refer to FinCat, and then an enhanced version of FinCat which we refer to as FinCat 2, which given a financial text, so the tool looks somewhere like this. You give it a text as input, it will point out the numbers and it will say what whether these numbers are in claim or out of claim. Next is exaggerated exaggerated numeral detection. So just like I am talking right now, when sir asked me that how long will the presentation be, I said that it will be for 30 to 45 minutes. Now, while speaking in the flow, I might lose track, and instead of 45, I can just say 4500 by mistake. This mistake generally may happen because when any of the CFOs, the chief financial officers, are giving the earning calls, they are saying, sharing details about the financials of their company, they can also commit mistakes. How can you effectively flag them? If we have this kind of systems in place which will be able to effectively flag these human errors, that will be immensely valuable. So for that we came up with this architecture. This is again simple architecture. We give an input text, whatever target numeral we mention that as num. We used a ACC word-based model to get the contextual embedding, followed by a neural network-based classifier. By removing neural network, we also tried fine-tuning ACC word-num model, but that didn't perform well. This architecture performed well, and we came up with the entire tool which has been hosted on Hugging Face. Anyone can come here, enter a text, press on this button, get numerals. It will mark the numerals, select the numerals, and get whether these numerals are exaggerated or not based on the context. So yeah, here we presented a framework to detect exaggerated numerals followed by a tool. Now I would like to present something which is very interesting. Tweets are made not just by general people like us, but also important celebrities. Now tweets by some celebrity can result in market fluctuations. I will give you an example. So this was how the price of Bitcoin, that what you see in red is how the price of Bitcoin was moving. Suddenly Elon Musk tweeted that Tesla won't accept Bitcoins any longer, and the price of Bitcoin, it crashed. So given the tweets which are made by executives who have a good foothold and who have a large number of followers, how, I mean, given a tweet by executive, can we come up with some architecture, some model, some study, and understand whether these tweets are responsible for moving the market or not? So for that we collected the data from Twitter. We collected two sets of data, two sets of tweets by executives and also by non-executives, I mean the general public. We predicted the market using the sentiments from the tweets and without using the sentiments from the tweets. The results which we have is, we established that social media posts by executives have deeper influence on the price movements of the stocks. Sentiment prediction, we proposed how to use sentiments for social media to accurately predict close prices. And finally, we also made a comparison, Reddit versus Twitter. We proved that Reddit shows a similar trend as Twitter, but Twitter is more effective when we want to measure how much effective, I mean when we want to measure the effect of executive tweets on the close prices. Now I would like to present another task from this domain, which is the financial argument analysis task. So for this task we had the data in Chinese as well as in English. The task is, first task is, we have a text and it's a simple classification task, premise or claim. These are the two things which we need to classify. It was annotated data. Second is, given two text, we need to classify whether these two are supporting each other, attacking each other, or they are not related. It's a kind of natural language entailment task, and we had a similar kind of task for Chinese as well. Here also we tried with various architectures. Finally, a cross-encoder architecture with Finbert at the backend that performed best for us. So till now I presented some of the shared tasks in the last two chapters, some of the shared tasks which we have done. Now how we brought in our learnings from those into the Indian domain, that is something which I would like to present next. So the next chapter I named it as Indic investing. So in Indic investing, first I would like to give a context. When I started with, I said that in India only 3% of people in India, they make investments in various stock markets and other places. That data was from 2022. Now it has increased. Now around 9.5% of India, they invest. Okay, so people are gaining the interest. Since people are gaining the interest, we need to be cognizant that whatever investment they are doing, they are not led astray. So here, for the first task which I'll present is financial argument analysis in Bengali, followed by IndicFin NLP, financial natural language processing for Indian languages, and finally predicting success and ratings of Indian IPOs, as Indian IPO has been hot over the last couple of years. So, firstly, financial argument analysis in Bengali. I presented this data set and the task which we have done it for Chinese. Now, we thought that why can't we make this data set work for Indian domain? In Indian domain, we don't have this data set annotated. So what we thought is, let's do one thing. Let's translate the Chinese data to Indian, some of the Indian languages. We started with Bengali. We translated the Chinese data using some of the ready-made data set translation tools which are available.
Data based on their environment. Do you think that is applicable in Indian context also, or just for modeling?
Yeah, so generally, culturally there will be difference. It will be 100% applicable. But for India, when we were doing this task in 2023, the ESG thing was not hot. So people were not talking much about it. We didn't have the data set for the Indian domain. Recently, after 2023, 2024, this picked up and this is booming. But back then, it was not a popular domain in India, for the Indian domain. And we didn't find any data set available for the Indian domain. So we saw that let's try this out. If it works, it's good. Otherwise, let's just see how it works. So we translated those Chinese dataset into Bengali. Since we used some of the readily available machine translation tools, we are not confident that whether the dataset which we have obtained is good or bad. So what we did is, once we have this dataset translated into Bengali, we manually verified them to get an understanding of the threshold. So there are certain similarity scores which is able to calculate similarity between text in different languages. What is the optimal threshold that we got through annotation? Then what we also did is, once we have this dataset in Bengali, we again translated it back to Chinese. Now I have two sentences in Chinese. What is the similarity between them? So use bird scores, Homer score to get a similarity. Now based on this process, our annotation and also this, what we have is the dataset which we obtained has reduced drastically. We had only a few number of instances, but again we had this dataset specific for the Indian domain, that is for Bengali, and we tried with various models. What we found is bird-based multilingual model. It performed best for this use case. We also did it for both the tasks, that is the pair-wise classification and also the individual classification. For both this bird-based multilingual worked best. We also came up with a tool so that people are able to do it effectively without running our codes and all, just from the user interface. Now is something which is which we presented at Ref Colleague. This we did for 3 languages: Hindi, Bengali, and Telugu. So the same tasks which I have been discussing till now, we thought that we have gained an understanding by participating in this shared task. We have the data set. How can we make it work for the Indian domain? So we translated those data set to 3 Indian languages. Why 3? Because I had annotators for only 3 languages. So we translated them using the same annotation procedure. We looked at the quality, and then we came up with similar approaches for the exaggerated numeral task. What we used is, instead of translating, we had the budget speeches available for Hindi, Bengali and Telugu speaking states. So the budget speeches, financial budget speeches were available. We took the dataset from there. Samantarar dataset, Samantarar data corpus, it was also available for the Indian domain. There also filtered out the relevant financial text, and we did this task. Same for exaggerated numeral, we found that when we were using multilingual word followed by an HCM, it was performing way better than any of the models. For sustainability, we translated the dataset as it is, and we came up with the models. Here we found that when we instead of doing the operation on Indian languages, if we translate them to English and then we do the classification, it was giving us better results. Same thing for the ESG as well. So ESG, we had to roll one level up after translating the dataset and after keeping all the checks and balances to ensure data quality. The dataset has reduced immensely. So from ESG concepts, we have to move one level up ESG theme, because at that level we had some dataset in place. So here also for these three languages, we created these systems, and these were quite high precision support and high multilingual models. Now I would like to discuss something relating to the Indian IPOs. So Indian IPOs have been quite aggressive. There have been multiple IPOs over the last couple of months, like Misho IPO, Lenskart IPO and all. So for this, what happens during an IPO is a company becomes public, it issues shares, and investors, they bid for the company shares. After the IPO, they get the shares. Can we come up with some model which will be able to predict what will be the prices of these IPOs? When a company participates in an IPO, it has to submit all the relevant financial documents to SEBI, which is the market regulator. From those documents, can we gain some insights, and can we guess from before what will be the prices? That was our task. For this, what we came up with is, after experimenting with various things, we are using some numeric features for the company, like what was the issue price of the IPO, what was the lot size, what was the revenue, what was the assets, and so on. Some categorical features, like which industry did the company belong to, what was the sector, what was the price band, what was the issue type, and all. Then some text features. Now these text features are, whenever the company is participating in the IPO, it has already submitted these text documents, which are around 300-400 pages, to the SEBI. From this, we did OCR. Wherever there was image, we got the text, and wherever there was text, we kept it as it is. We chunked them. Then we consulted people who regularly invest in the IPOs. We got a list of questions they look for in these documents. We also looked at some online portals to get a list of the questions which are very relevant sections from these documents which people use to make decisions. So accordingly, we used a RAG, retrieval augmented generation based framework. We got the relevant chunks from the documents, and then we trained a Llama 3 model for the, Llama 3 model was used to get answers. So once we have these answers, for these answers we tuned a debata based model, which is again a variant of word based model for longer context. We got the probability that based on this given text documents, what will be the probability of this company, what will be the probable price of this given company, which when it will get listed. We got this probability. We use this probability as well as other features like the numerical and categorical features, and we trained various machine learning models like random forest, 60boost, LightGPM, and so on. And finally, we come up with the final output, which was giving better results than individuals. So here our contributions are, we contributed to two data sets. One for the main board IPOs. Main board IPOs are the ones which are bigger in size. SME IPOs are the ones which are smaller in size. So we give two data sets. We created two data sets. Methodology, we proposed a methodology which uses natural language processing as well as machine learning based models to get an insight of this, to get an understanding of the probable price of the IPO. We propose a framework to extract portions from the documents. So we also propose a framework to extract relevant portions from the documents which are submitted to the SEBI, like the rate hearing prospectus and the draft rate hearing prospectus. And we also benchmark with the grey market price. So grey market is the illegal trading which goes on. Now based on this grey market price, how can we come, we benchmark that if we're using just the grey market price, which is where the illegal trading is going on, and we are not using our model, what will be the relevance? We found that for mainboard IPOs, grey market price is doing a good job, we don't need our model at all. But for the SME IPOs, the small and medium scale enterprises, our model is doing better than what is equivalent in the grey market. And we benchmark with Gemini, Llama and other models to get an understanding. So the final task. Yeah. So the final. This is the final task where we automate the process of rating an IPO. Suppose we have this rate hearing prospectus where based on the rate hearing prospectus, the expert they read this prospectus and they give some kind of recommendation: avoid, neutral, or apply. Now, how can an AI bot do that? For that we came up with this architecture, where also this is similar to the previous one, where use a RAG-based framework. We got some questions, we could answer to the questions. We create a summary of these answers, and finally we train a classifier model to get the recommendation. Yeah. So here also we generated two India specific data sets, and we also use some novel methodology which uses retrieval augmented generation along with fine-tuned small encoder models, and it outperformed some of the large language models like Llama 3 under zero-shot settings. This is whatever I have done till now, all have been incorporated as a single tool. Most of the things which I have done, and this is has been hosted in Hugging Face, where the single tool does most of the financial tasks which I have been doing. So this is how the tool looks like. So this is the conclusion and the future work. Overall, I have contributed to 16. It's hosted in Hugging Face.
And data set also?
All the datasets are available in Hugging Face. Some of them in Git, so all the links are there. And this has been, all the datasets have been released under the academic license. So whoever wants to do research can take this forward. So yeah, these are the key themes which I have discussed. And the next step, obviously, from here would be embracing multimodality. I have just used images, and I have not used speeches at all. Images, videos, and speeches, like using reinforcement learning. And whatever work I have done till now, all the matrices which I presented, these are all academic matrices, like from score, the precision, recall. But how much impact it is creating in real life, that has not been measured at all. That is something which is very important, and we should look at whatever things we are presenting, how much relevance it is creating in the present world.
Like sustainability metric, how do you measure the sustainability?
Yeah, so for now, since it was a classification task, all the standard matrices have been used. But the task is, what we want to do is, what can be a possible future step is, we deploy this model in production. Suppose for the IPO, we deploy these models are available. This model has been open source. These models are deployed in production, and people start making decisions from this model. How effective are their decisions? That will be the real measure, which is a kind of limitation of the work which I have done. Now, some of the good news is people are taking financial literacy into consideration, and schools in Hyderabad, they are also giving financial literacy classes. AI and finance, they have been mutually integrated, closely integrated. People are using AI-based tools for finance, and we have this perplexity, which is also specifically available for the Indian domain from this year. So people can now clarify their doubts, ask financial questions relating to the Indian domain using perplexity. So yeah, acknowledgements, thanks to my supervisor, my mentor, and my parents who are also here. Thanks to ACM India for providing me the travel grants, my lab mates, collaborators, friends, colleagues, and employer. So yeah, the final thing, we say that India's contribution to the world of mathematics. We say that India's contribution to the world of mathematics okay, yeah, sure. So we say that India's contribution to the world of mathematics has been zero, and we can say that our contribution to the world of financial natural language processing is infinite, because we are presenting Indian financial narrative inference tasks and evaluation at IGC NLP workshop, which is the event for NLP workshop being held this month only. So we'll be presenting this paper there. So we can say that our contributions has been infinite. So this is the last slide. Just to conclude, what I want to say is, financial literacy is one thing, but taking this, making decisions, and being financially intelligent, understanding that this mutual fund is good for me is one thing, but investing in that mutual fund and finally making profits, that is something which would like to, that is something which is the next step ahead. So Vidya is like, Vidya or knowledge, it shouldn't be a burden for us. Rather, we should try to use the best possible use of it, and that should be in a positive way. How can we make the best knowledge, make the best use of the knowledge which we have gained for making financial decisions and making the lives of everyone better? So that's the conclusion.
Thank you.